Good day, everyone. You're welcome to Botito channel. Today, we'll be talking about theorems of parallelogram. We are still under theorems of plane shapes. We just finished with the theorems of triangle, and today we'll be talking about that of a parallelogram. Let's talk about parallelogram. What is a parallelogram? Parallelogram is a four-sided polygon which is a quadrilateral, which has its opposite sides to be parallel to each other. What do I mean by that? It means you have two parallel lines to opposite each other, and the two parallel lines will make a four-sided polygon. You can see from this shape here, the line here and the line here are parallel to each other, and also the line here and the line here are also parallel to each other. And these four parallel lines, the two pairs of parallel lines, makes a four-sided polygon. I used to ask a question: is rectangle also a parallelogram? Yes, we can say a rectangle is also a parallelogram, but they are under special parallelogram. You can see this line and this line are parallel to each other, and also this line and this line are parallel to each other. Because of that, it is also a parallelogram. The same thing applicable to square. Square also is a parallelogram. Square also is a parallelogram. Rhombus. Rhombus is a parallelogram. You have this line parallel to this line, you have this line parallel to this line. This is the most popularly known parallelogram by everyone, but these also are parallelogram. They are just a special types of parallelogram. And under this parallelogram, we'll be talking about some theorems, in which I highlighted three major and important theorems we'll be talking about under parallelogram. Stay tuned and keep watching. Welcome back. Now let me use this parallelogram to illustrate what all these three theorems are talking about in a parallelogram. The first theorem says opposite sides of a parallelogram are equal. Already, before we can call it a parallelogram, we said the opposite side must be parallel. But they will not only be parallel with each other, but they will also be equal to each other. Let's call here A, here B, let's call here C, and here D. For you to know that something is, for you to call a shape a parallelogram, we are trying to let you understand that the length AB will not only be parallel with DC, but also will be equal to DC. Same thing applicable to AD, it will also be equal to BC. Not only that they will be parallel, although we know that AB is parallel to DC and also AD is parallel to BC. But it is not that they will be parallel alone, but they will also be equal to each other. And based on this figure here, you can see, based on the illustration, that this line will be equal to this line as long as this line and this line are also equal to each other. And that takes us to the next theorem that says the opposite angles of a parallelogram are equal. The opposite angles of a parallelogram, we are telling you that the angle here is equal to the angle here, and also the angle here is equal to the angle here. Let's prove that. Let's assume we draw a line to bisect this line AC here. Let's assume we draw a line to bisect this line AC here. Automatically, you will discover that the angle here, which is the angle DAC, will be equal to the angle AC ACB. Why? Because they are alternate to each other. The angle here will be equal to the angle here. They are alternate to each other. Let's call them X. If here is X, here also will be x. That is what we are saying. Let's call the angle x. And also, let's check it the other way around also. The angle D, the angle DCA, or you can call it ACD. The angle DCA will be equal to the angle CAB. That is, the angle here, let's call it y, will also be equal to the angle here. Yes, let's call here y also. So here is x, which is equals to here. Here is y, which is also equals to this place. Which means your angle D here, let's call it angle ADC. The angle ADC plus x plus y is equals to 180 degree. That's the sum of angle in the triangle. That is, whatever angle that needs to be here plus this x plus this y must give us 180 degree. Sum of angles in a triangle. And if the sum of the three angles should give us 180, therefore your ADC must be equals to 180 minus x plus y. 180 minus x plus y. That is what your angle ADC must give us. And also, let's look for angle ABC. Our angle ABC also will be equals to, our angle ABC plus x plus y also will be equals to 180 degree, because we have x and y here with the angle ABC. Therefore, your angle ABC also will be equals to 180 minus x plus y, which will also be equal to what ADC gives us. We can then say your ABC is equals to your ADC, because they both gives us 180 minus x plus y. Let's say here is z, here will also be z, which means your angle ADC is equals to your angle ABC. And also, if here is x plus y and here is x plus y, it shows that they are also equal to each other, which means the sum of angle here is equals to the sum of angles here. And that proves the second theorem I have under this theorems of parallelogram. Now let's move to the third theorem of the parallelogram. Theorem says, if we draw a diagonal and another diagonal crossing each other in a parallelogram, that the two diagonals bisect each other. And how are we going to prove that? You will notice that if you draw a line in this form, notice that the angle here will be equal to the angle here. We said they are vertically opposite each other. That is what under the basic theorems of angle. The angle here is equal to the angle here, vertically opposite each other, and also the angle here will be equal to the angle here, vertically opposite each other. That's what the theorem says. Therefore, you can proceed. Since the total angle here is equal to the total angle here, any line that bisects the angle here and also join this angle here, we make whatever angle here to be equal to the angle here. Therefore, the angle here will also be equal to the angle here. The angle here will be equal to each other. The angles here will be equal to the angles here. And also, the angle that will be here will be equal to the angle that will be here. And let's remind ourselves under congruent triangle, if the angle here, the angle here is equal to the angle here, the angle here is equal to the angle here, and the angle here is equal to the angle here. That is, you have your let's call this point O. You have your AOD to be equals to BOC rather, and also you have your ADO, your ADO to be equals to CBO, sorry, to be equals to CBO. Also, you have your BCO to be equals to DAO. Since all these angles are equal to each other like that, we can now check the corresponding sides to be equal also, because it shows they are congruent of each other, which means the line here is equals to the line here. The line here will be equal to the line here since their angles are equal, and also the line here will be equal to the line here. Sorry, will be equals to the line here. And this shows that if the line here is equals to the line here and they are equal to each other, the total length will be bisection of these two lines, which means this will be their midpoint, and this also serves for the midpoint of this line here. That is, your line AO is equals to your line CO, your line BO is equals to your line DO. If all these fall, if these two lines are equal to each other and these two lines are also equal to each other, it means your AO plus your CO will be equals to your AO is equals to your AC, and also your BO plus your DO will be equals to your BD, which means this line are just the bisection of these straight diagonals. And that brings us to the end of the three theorems that we have today. Stay tuned and keep watching. Don't forget to subscribe to this channel if you're just seeing this video for the first time. Comment any question you have under this topic or under any other topic in mathematics. Don't forget to like and share. Thank you very much.